Hello, and thank you for joining me for today's discussion on states of matter, and specifically the kinetic molecular theory. Whoops, that was a nice line. So, at the end of today's lesson, you'll be able to define and explain what is meant by this term kinetic molecular theory. You'll understand the difference between temperature and thermal energy, and you'll be able to describe the molecular movement of solids, liquids, and gases. How do particles move when they're a solid, a liquid, or a gas? So here we go. For starters, your kinetic molecular theory is really kind of nice because it goes kind of piece by piece. So the word kinetic refers to motion. We're going to talk about kinetic energy next semester. Kinetic energy is energy of motion. So kinetic means motion. Molecular refers to molecules, and theory is an idea, a well-supported idea. And so this theory states that all matter is made of atoms, and the atoms are constantly moving. And so it is the idea that all matter is made of atoms that are moving. And so idea, atoms, moving, or idea of moving atoms. It all kind of goes together. These atoms are constantly colliding with each other and the walls of their container. And then these are just some examples of molecules that can be moving around freely. There are some premises, there are some things that need to be true for this to happen. So there's three parts to the kinetic molecular theory. One is that all matter is composed of small particles. Call them atoms, call them molecules, call them ions. All matter is composed of small particles. Two, those particles are in constant random motion. So solid particles look like this, liquids move a little bit more, and gases are free flowing. We'll talk about that shortly. The last one, particles are colliding with each other and the walls of their containers. So you see these particles are hitting each other and the walls of their container. These are the three premises behind your kinetic molecular theory. So then begs the question, what about energy when it comes to all this? What is energy? So energy, by definition, is the ability to do work. Okay, well that's all good and well, but now we've thrown this word in there. I don't know what work is. So work. In science, work is a term that is, it's a quantity that is achieved by taking a force, by multiplying a force over a distance. So force times distance equals work. But then because we have this energy, are there different types of energy? And the answer is yeah. There are a number of types of energy. In this class, we're going to focus on the two main ones, which are potential energy and kinetic energy. And so real quick, what's kinetic mean again? So think about that. Kinetic means motion. And so kinetic energy is the energy of motion. And we'll talk about potential later. If we're talking about energy, we're going to talk about what's called temperature. And you guys know, you've read temperatures before. Temperature measures the average kinetic energy of the particles in a substance. So it looks at the average kinetic energy of the particles in a substance. So the average amount the particles move in a substance is your temperature. That's different from thermal energy. Thermal energy measures the total kinetic energy of the particles in the substance. So think of it like tests. If I take the class average, I add up all the scores and I divide by the total. If I wanted the class total, I would just add up all your scores. Which one's going to be bigger, temperature or thermal energy? It's always going to be thermal energy. Has to be. Because as long as there's more than one particle, it's always going to be thermal energy because I'm adding together. I'm not taking the average of the two. And then so we've talked 0 degrees Celsius is the freezing point of water. There's another number though, a zero that's really important. This is called absolute zero, which is measured on the Kelvin scale. This is not okay. This is 0 Kelvin. At absolute zero, there is no kinetic energy, which means particles stop moving. So this is really important and is a term that we're going to use throughout the semester. So here's a joke. So it teaches about absolute zero and okay, 0 Kelvin. Haha, hee hee, ho ho, funny, funny. All right, really quick review. What is the kinetic molecular theory? What are the three premises of the theory? What is energy? How are temperature and thermal energy different? You're going to answer this question a lot in the next couple weeks. But answer those questions, pause the video, answer them, and then hit play, and we'll continue on. We'll finish up this section. Okay, now we're going to talk states of matter, because this deals with energy. So there are 3 states of matter we're going to talk about. First one is a solid. You guys know what solids look like, but in terms of particles, the particles in a solid are super close together, that all they can do is vibrate in place. So this particle moves, and it hits this particle, which vibrates, and it's this particle. They just vibrate back and forth. There's a specific pattern and arrangement. For example, the table you sit at, the chair you sit on, have looked the same since the first day of school. It doesn't change. Solids hold their shape, they hold their structure, they hold their appearance. Which means solids have a definite shape and a definite volume, which is important. So those 2 terms define or describe a solid. Definite shape and definite volume. If we talk about a liquid, liquids have particles that are close together, but they are not held in place. So think of the water bottle in front of you. You can take it, you can flip it over, and the water goes from the bottom of the bottle to essentially the lid. So these particles can flow. Liquids have a definite volume. The amount of water doesn't change, but it has an indefinite shape or a changing shape. Because if you dump your water bottle out on the floor, please don't, it will make a different shape. It's not going to come out looking like it is in your bottle. So it takes the shape of its container, is a liquid. So all of these, if I dumped them on the floor, would just be a big puddle. They wouldn't look like this without the beaker or without the flask there. And the last one is a gas. Gases are different. Gases have no definite volume and no definite shape. They expand and they fill their container. For example, if this container was opened up, these gas particles would escape and they would fill whatever room they're in. They would occupy whatever space they have that would contain them. Particles are far apart and rapidly moving, is a characteristic of gases. All right, here's your last review. I would like you to tell me how solids, liquids, and gases differ in terms of particle movement. What are differences in solids, liquids, and gases in terms of shape and volume? And what is it called, out of curiosity, when a solid becomes a liquid, what do we call that? What about a liquid becoming a solid? Gases becoming a liquid? And liquids becoming gases. We're going to touch these in the next chapter, next section, but I thought I'd at least put them out there to see what we can come up with. Thank you for your time and attention today. I look forward to working with you as we continue this unit. Let me know if you have questions, and we will see you next time.